So we can say that this function is coming out to be continuous. Okay. Now let's see one more problem. Tell me, what is the value of limit x tending to 1, x square minus 1 upon x plus 1? Can you tell me the limit of this function? X square minus 1 upon x plus 1. Now you must see what is the point of breaking of this function. What do I mean by breaking of this function? What do I want to say from breaking is that at what point or at what value of x the value of this function is coming out to be not defined. Now the value of this function is not defined when the denominator is equal to 0 and this denominator is coming out to be 0 when x plus 1 is equal to 0 or when x is equal to minus 1. So at point x is equal to minus 1 this function is breaking, right? So we can say that this function is not defined. This function is not defined at x is equal to minus 1. But I have to check the limit of this function at x is equal to 1. So what will I do is, I'll just try to put the value of x is equal to 1. If that works out, then I will get the limit. If it doesn't work out, I have to look at some other way. Okay. If I want to substitute the value, this comes out to be 1 square minus 1 upon 1 plus 1. This is equal to 0.2, which is equal to 0. So we can say that the limit of this function is equal to 0 at this case. Or you can solve it something like this, that this is equal to x minus 1 into x plus 1. By basic identity, a square minus b square, a minus b, a plus b. And this will be equal to x minus 1. So as the limit of x approaches to 1, this thing will become 0. Because as x approaches 1, 1 minus 1 will be equal to 0. Now I'm going to change this question a little bit. Sorry. In spite of writing plus 1 in denominator, I am writing minus 1 over here. Now the question is limit x tending to 1, x square minus 1 upon x minus 1. Okay. I have to find the limit of this function as x approaches 1. Now one thing is pretty much clear, that at x is equal to 1, this function is not defined. Why is the function not defined? Because at x is equal to 1, this function is becoming 0.0. Now guys, whenever you get 0.0, you just can't cancel out both these to get 1. This is not right. So this is called an indeterminate form, which I will discuss in the next class, that what are the different indeterminate form and what are the standard limits we have. So this is an indeterminate form. So you cannot put the value of x is equal to 1. So what can I do is, I can factorize this one. X minus 1, x plus 1 upon x minus 1. And this thing will come out to be, can you cancel this out? No. Now we know that as x approaches 1, now the value of x is not equal to 1. If the value of x were equal to 1, these two would have cancelled out and we would have got nothing. Okay. This would be 0.0 form. So the function in that case, the value of function, the limit of function at that case will be equal to not defined. But since I have to calculate the limit, now the x is approaching to 1. X is not 1. X is approaching to 1. So the value of x will be slightly greater or slightly lesser than 1. So if I subtract 1 from here, this will still give you a finite number. So this will be of a finite upon finite form. Now we know that if two identical terms are divided, this will give you cancellation. So this is nothing but limit x tending to 1, x plus 1. And this comes out to be 2. So the limit of this function is equal to 2. But can we say that this function is continuous? No, we cannot say that, because the value of this function, the value of x square minus 1 upon x minus 1 at x is equal to 1 is not defined, right? So we say that limit no doubt exists, but continuity, is the function really continuous? The function is not continuous. Okay. So let's see one more problem. So I already told you what is the significance of box x or the greatest integer function of x. Now let's see the limit x tending to 3 box x. Right? I have to calculate this limit. Now in this case and the previous case was x square minus 1 upon x minus 1. There's a difference. In this case, I just put the value. When I got the definition of the function that is equal to x plus 1, I just put the value that x is equal to 1. But in this case, I just cannot put the value if x is equal to 3. Why I cannot put the value? Because the definition of the function, the definition of this function changes at all the integers. I'll tell you what is the meaning of this term. If I try to see the graph of this function, it will come something like this, as we have already discussed. And at x is equal to 3, the value will be at x is equal to, this is 2 and this is 3. At x is equal to 3, the value of the function is 3. But as I am looking at x is equal to 3 from left hand side or right hand side, the value is not equal to 3. We can say that from left hand side the value is equal to 2 and from the right hand side the value is equal to 3. And what is the meaning of definition of function? That for all the numbers from 1 to 2, the function will be, the graph of the function will be this one. For all the numbers from 2 to 3, the graph will be this one. While in this case, the graph was continuously this one. In case of x plus 1, the graph was continuously this one. Right? At x is equal to 0.1, the graph was continuously this one. While in case of box of x, the graph changes. So in this case, I have to see both the limits. I have to see the LHL as well as the RHL. Okay. So write it down. This is very important stuff. That when do you have to see the left hand limits and right hand limits both, and when do you not see these limits? The limits LHL and RHL should be seen when function changes its definition. Okay. If the function changes its definition, the LHL and the RHL should be seen. Clear? So in this case, the left hand limit, just write it down. This is very important. If you write it down, so I can erase this. So this becomes the left hand limit can be written as limit x tends to 3 minus, in the superscript I am writing minus sign, x. Now can I write it? Now you will see a new thing. I can write this 3 minus as x is equal to 3 minus h, where h approaches 0. I can write this 3 minus as x is equal to 3 minus h. Now what I mean by 3 minus h is that I am very close to h, but I am not at x is equal to 3. I am very close to x is equal to 3, but I am not at x is equal to 3. So that's why I wrote 3 minus h. So this h, the value of h will be 0.000 million zeros 1. Okay. After a million decimal zeros, I am getting 1. So that can be the value of h. Okay. So I can write it as, now the limit will change from x to h. Now we are dealing with h here. I am writing 3 minus h over here. And now the variable here was x. The variable in this case is h. So here we have h tending to 0. Now we know that for all the numbers which are lesser than 3, the box of those numbers will be equal to 2. So this limit will come out to be 2. With the graph also we can see this. Okay. But if I am going to see the right hand limit, this was the case of left hand limit. If I want to see the right hand limit, this is x tending to 3 plus box of x, or limit h tends to 0, 3 plus h, I can write it like this, where h is tending to 0. Now the box of this function will come out to be 3. Since for a number slightly greater than 3, the box of the number will always be equal to 3. In this case, the LHL is not equal to RHL, therefore, this limit does not exist. So, the limit does not exist. I am writing it in another short form, DNE, which means does not exist. Okay. In the next lecture, we'll discuss a little more about the definition of limits and what are the basic limits, what are the basic and some standard limits which you have to remember always and which are very important from all the questions. So you just need to focus on the definition of limit, that it is the value of the function in the neighborhood of x and in the domain of x. We're not talking about the value at the x value of x. We're not talking about, if I say that limit x approaches 1, I'm not saying that what is the value of the function at x is equal to 1. I'm saying that what is the value of the function in the neighborhood